Good morning, good morning, good morning, good morning. How's everybody? Happy Tuesday. I believe everybody is here. So we just jump right on in. All right, so we are testing tomorrow. I always have to remember what day I see you. So we are testing tomorrow. We finished the unit on macromolecules. However, we are including um, what makes a living thing because macromolecules are the things that add to our nutrition part of what makes living things a living thing. So we're going to go over the study guide today. I'm going to walk you through it. Um, what I also want, what is not on the study guide, is the assignment that you had a little while ago um, on Ms. Gren. Ms. Gren outlines all of the things that living things must do in order to be a living thing. If you leave anything out, if the object that you're looking at is missing any of these, then they are not a living thing. And they always use the virus as a classic example. A virus can move, a virus can not reproduce without the help of another living thing. It doesn't carry on respiration. It doesn't react to sensitivity, and it doesn't feed. Okay, so it does excrete and it does grow because it make new viruses, but it doesn't do all the other things. So if it's not doing all 7 of these topics, then it is not considered a living thing. Okay, so again, we kind of think of a virus as a living because it's in a living thing, and you can make more viruses, but the virus cannot do it by itself. It needs a host in order to do that for it. So the virus is not a rock. A rock can't move unless you move it. You can drop it and break it into a bunch of pieces, but then they don't grow back. So you can make more rocks, but they needed your help to do that. They don't carry on respiration, excretion, or nutrition, so they are not living things either. So again, when you're looking at is something a living thing, you want to line it up against this list of Ms. Gren. So remember Ms. Gren so that you can remember what all of the topics are for characteristics of living things. All right, and that was in your module from the first session. So I'm going to come out and show you where that was in case you need to locate it. It is in the first section on science life, and it was your, stop jumping. It was your science assignment, what makes a living thing a living thing. So that's where you'll find Ms. Gren. All righty. Then we have completed this, and I have to go to Nearpod and get your scores from these two. Remember the protein one, we got stuck on that. So all I really need for protein is your participation up to the slide where the video isn't working. So I just need to see that you participated up to that point, and I'll put those scores in the gradebook today while you're working on the worksheet. All right, so if you scroll down, you have a macromolecule review page. Now, and then you'll see it twice because I'm giving you credit for having done it. Okay, so you get some bonus points, and you get bonus points because we're doing this together. So basically the bonus points are where you're with me, where you're participating, and did you take the time to upload it? All right, so I downloaded mine on with the PDF because I don't want it in my documents, but you might want to download the other link that says a study guide in doc form so that you can write on yours. Okay, so I'm going to come back over here. So it starts off, The main question before we do the test is to make sure that you've completed all assignments. And I just checked the grade book, and aside from the Nearpod assignments that I have to put in, it looks like everybody's up to date, which is wonderful. That never happens. Everybody's got everything in. Great, great, great. All right. Second thing is to look at the vocabulary. So you see, we got a lot of vocabulary with this section. A couple of things I want to touch base with you because we didn't, things in this last column. We did not use the term denaturization very much. Actually, I'll go back to that in a minute. When we talk about proteins is one of our macromolecules, and we were saying that all living things function best at an ideal temperature. Proteins in particular, they function best at a given temperature. And if the temperature gets too high, the protein will cook. So think of an egg on the stove. When you put the egg out there and you start to cook it, then it changes form. It can't go back to the jelly-like looking thing that it was before. And it's a totally different um, molecule or food source. When you denature a protein, you change its shape, and then it doesn't work anymore. So in your body, we don't want denatured proteins. We want all your proteins to work the way they're supposed to work. In particular, enzymes. Enzymes are proteins, and they have to work at, I'll send you that link in a little while, Ryan. Right now, I need you to be with me. And then you need to tell me which one you want. There's two: carbohydrates and proteins. All right, so I need everybody to be on this worksheet page so that you focus on this assignment today. All right, so again, denaturing. If the proteins are denatured, they will not work. If an enzyme is denatured, it does not work. And enzymes are needed to make reactions happen. If they are not working, your metabolism slows down. A lot of things that are supposed to be going on will not go on. There's no protein building, there's no nothing going. That's when you start to feel sick and sluggish and want to pass out because nothing is working, because the proteins are not at the temperature that they want to be. In other words, on here, and we'll come to these later, is the energy, these two words, ATP. ATP stands for adenosine triphosphate. It is the energy carrying molecule. That's its definition. Its job is to carry the energy around the body. So we didn't talk about those in our notes very much. So I wanted to point those out. Everything else we pretty much will run into as we go through this review sheet. Okay. All right. Any questions so far? So I'm going to carry you a little ways through. Actually, the worksheet says it's locked until tomorrow. All right, so it shouldn't. It's in the module. Okay, let me check on that. It should not. Are y'all in the module? The other one, okay, you're looking at you're on what's available tomorrow is I'm giving you credit to turn this in. That's not available tomorrow. So you cannot turn it in until tomorrow. So that's what's available tomorrow. What you should be on today is the worksheet that is in. So there's no worksheet in there. That's just a space for you to upload the completed worksheet from here. Okay. So everybody should be in Canvas. It should be the page right after the water lesson. All right. And that's what you should be looking at. Is everybody with me? All right, so this is in your module, and you should be downloading one of two. I guess I recommend that you download the doc form so that you can write on it. I've been downloading the PDF so that, because I'm just looking at it, I don't want to download it. But either way, you can download it and save it as a doc. Either way, don't worry about um, don't worry about this link down here. That is not for you to do. That is not for you to do at all. We're just worried about the study guide. Okay? Are we all good? Everybody with me? Okay. All righty. So back over here. Right, number one. Macromolecules all have similar elements, and the elements are carbon, hydrogen, oxygen are the main three, and phosphorus is in most of them. It's just, no, never mind, nitrogen. And we can add phosphorus too. Phosphorus is in some of them, but most of them have carbon, hydrogen, and oxygen. Some have nitrogen and some have phosphorus. So those are the extra. So there's three that are common to all. Okay. All organic compounds possess one thing. All of them contain the element carbon. Okay, well, I was explaining to you that if you're doing chemistry, there's two types of chemistry: organic chemistry and inorganic chemistry. Organic chemistry studies everything that has to do with carbon. If it doesn't contain carbon, so it almost answered its question. And again, folks, I'm going over the answers. There's no reason why you shouldn't get the bonus points because we're giving you the answers. So if you're following along with me and typing in your answers, you should have a completed worksheet to get your bonus points. All right, if it does not contain carbon, it is called inorganic. So those words are up here on your vocabulary list. Or whoops, too much. Organic and inorganic. Okay. All right. The four macromolecules, and I'm going to leave you to fill in what the monomers are. We're going to switch over to our study guide, your graphic organizers. So the four that you want to put in, and like I said, I'm going to switch over to let's see if I can do this without going around the block. And my computer has been very slow. Come on. Actually, it is going to be easier if I do this. All right, the other thing I want you to remember that you have as a study tool that you will be able to use on the test is your macromolecule graphic organizer. So we're going to look at that for a minute. So what you need to answer that question is your handy dandy graphic organizer. All right. So in the first column, and I added water, but they're not asking you for water. The first four are the things that you want to put down. So you want to say protein, carbohydrates, lipids, and nucleic acids. Those are the four that they are looking for. Then the next question says, what is the monomer for each one? So for proteins, you want to say that the monomer is an amino acid. For carbohydrates, the monomer is a monosaccharide. And they're giving you three different examples of monosaccharides here: glucose, fructose, and galactose. They're all monosaccharides. And again, what you have to remember are your base words. So the base word for proteins is a peptide. So when you have more than one, you have a polypeptide. When you have more than one carbohydrate, you have polysaccharides instead of a monosaccharide. With fatty acids, it's a little different because it has its own unique name. Fatty acid is the monomer for lipids is a fatty acid plus a glycerol molecule. So you're pretty much looking at this picture over here. One glycerol and three fatty acids makes up one lipid monomer. And then what you have with this is long chains of these triglyceride molecules. So the triglyceride is your monomer, okay? So what this did was show you what the long chain looks like, what the fatty acid chain looks like, and then what the glycerol, the glycerol molecule looks like. So it's three fatty acids connected to a glycerol, and that makes a triglyceride, and that's your monomer. All right, nucleic acids. A nucleotide is your monomer. And a nucleotide is made up of three parts: a phosphate, a sugar, and a nitrogen base. So the phosphate and the sugar are constant. The sugar will depend on whether it's a DNA or an RNA. So if it's DNA, the sugar is deoxyribose. If it is RNA, then it is ribose. And remember, all sugars end in OSE. Okay, but generically speaking, it is made up of a phosphate molecule, a sugar molecule, and a nitrogen base. The nitrogen base can be one of four. Okay, it can be if it's DNA, it can be adenine, thymine, cytosine, or guanine. If it's RNA, it can be adenine, uracil instead of thymine, cytosine, and guanine. Okay, so the nucleotide is that base. Now, I didn't ask about water, but if we were looking at what one water molecule looks like, it's H2O. I always say it looks like the Mickey Mouse, where you have a large oxygen molecule with two hydrogens attached to it. And it's attached in such, and this is a question for later, but while I have the picture up, I will talk about it. And if you look at this picture over here, it shows you that there is a top and a bottom. When we talk about it's a polar molecule, there's a top and a bottom to a water molecule. The oxygen part is negative, and the two little hydrogens are positive. And just like a magnet has opposites attract, the opposite ends of the molecule are attracted to each other. So this oxygen over here is attracted to a hydrogen because the negative is attracted to a positive. And the same thing if you look at each of these, the hydrogens are attracted to the other oxygen on the other molecule. All right, so one molecule of water is H2O, if we were talking about monomers. And this, a lot of water would be your polymer, but it's just water. It doesn't have enough special name. It's just a lot of water. Okay. We need to remember that everything exists in the three states of matter: solid, liquid, and gas. So we have water as ice, we have liquid water, and we have water vapor. All right, I just covered that because we had the chart up. All right, so remember, keep this handy. You will be able to use it on the test. All right, let's go back to our, oh, I can do this right here. Okay, so let's go back to this. So that's what you should have had in the boxes here. I think I just explained how the water structure, what about it makes it polar. It has a um, positive end and a negative end. Describe how the polarity, uh, okay. Surface, it is a universal solvent because everything dissolves in water. It has surface tension because the characteristics of water may allow it to cling to each other for a lot of water molecules to cling to each other before they disperse. And we looked at that with the example of the water on the face of a penny. Capillary action is its ability to travel one molecule behind the other up what seems like a straw. So our capillaries, the plant has vascular organs that it just travels up so that it can get from water can get from the roots to the leaves. So all of these things allow it to be important for life. Surface tension is important because water can collect like on the surface of the leaf, water collects on the surface of your hand. It it doesn't go all the way through your skin just like that. It kind of collects a little bit. All right, you do not have to do number six. Number six, you don't have to draw. But what I do want you to know, let me go back over here. Um, I do want you to know that, so you look back at the water lesson. Again, you don't have to draw this. There's our penny, our drowning penny. Okay, this is our pH scale. pH stands for how much hydrogen is concentrated in a solution. So little ions of hydrogen. So they're measuring. If it is an acid, it's got a lot of hydrogens in solution. And acids are down here. They go from 0 to 6. And if it's got a lot of OH, now the OH are the other ions that will float around. And so when we were putting together molecules, we said we do that by dehydration. We remove a water molecule, but we did that by taking a hydrogen from one atom and an OH from another atom and putting them together. Let me see if I can. I'll find that in a minute, but let me stay right here for a sec. All right, so this is your scale. What we need to remember is water is neutral. It is neither an acid nor a base, and that's important. Blood also needs to be in this range of being neutral because you don't want your blood to be acid or base. If it has too much OH, it's going to be a base, and you can be a strong base. Like soap, some soaps can burn you and irritate your skin because they have a lot of OH molecules in them. And these things over here have a lot of hydrogen in them. Now, again, to neutralize any of these things. Whatever it doesn't have, we add the other. So if it's a strong acid, we're going to add some OH molecules to it. And so the H and the OH will come together and make H2O. So H2O is neutral, neutral. Okay, that's all you need to know. You don't need to draw this on your worksheet, but this is what it's referring to. Okay, so if you want to copy and paste this picture on there, fine, but you don't have to draw it. All right, so that's question number 6. All right, I'm going to stop for a minute and let you look at these questions 7 through 20. I need to do attendance. I'll be right back. So take a minute to fill in catch yourself up, and look at the other questions, and I'll be right back. Quick, because everybody's here. Mm, 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 mm. Okay, I see a lot of idle people. You're here, but you're not here. Mm-hmm. Where did my attendance go? Every time I open a resource, one folder makes the other one disappear. Okie dokie. All right, I am back. All right, carbohydrates are made up of three elements in the ratio of 1 to 2 to 1. And so what that means is most of them are made up of carbon. So there's one carbon, there's two hydrogens, and one oxygen. So it'd be carbon, hydrogen, oxygen is the order you want to put that 1 to 2 to 1. And an example, so number 8, an example of that would be our simple sugar glucose, which is made during photosynthesis. So when we later on we'll talk about the chemical reactions of photosynthesis and respiration, how they're related to each other. But when we say plants make their own food, the food that they make is glucose. So that's the word that goes there. And it has a chemical formula of C6H12O6. So when we look at this ratio, for every one carbon, there are two hydrogens. So we've got 6 carbons, we've got 12 hydrogens, and then one oxygen. So there's also a 6 oxygens to go with that 6 carbon. So that's our 1 to 2 to 1 ratio. Okay. All right. So number 8 is glucose. And this is the chemical formula for glucose. When we get to this section, you're going to have to memorize. That's about the only formula you're going to have to really memorize. C6H12O6. Okay. All right. Number 9. What are the 4 major polysaccharides that we see in nature? Polysaccharides are bigger sugars. Sucrose is table sugar, and that's just a disaccharide, but you can list that as one. Anybody have an answer for what the other 3? Let me let y'all talk to me for a little while. I'm doing too much talking. Polysaccharides. What are the most popular? I'll give you a minute to look that up. The most popular polysaccharides. All right, maltose is one. And again, notice it has OSC on the end. Lactose. And I guess you could put cellulose. You can put that's good. Um, and you can put sucrose on that list because it is not a monosaccharide. So you can put glucose on that list as well. Anybody have another one that's kind of popular? And remember, all of these have more than one sugar. And most of these are disaccharides. All right, there's a question. Can't think of it anymore. All right, there's another question for number 10, the one that we can't think of. It's called chitin, Chitin. Chitin. That is what is in the shells of sea fish, and that is a polysaccharide. Okay. Starch is considered a polysaccharide. Pectin is also considered a polysaccharide. I'm sorry, not yeah, pectin, which is the sugar that you're going to find in, it's kind of a protein sugar. You use that to make jelly jam. All right, that's number 10. Monomers bond together to make polymers. So this is a general question. We're not asking you which one. If it's a monomer, they bond together to make polymers. What three elements make up lipids? Just carbon, hydrogen, and oxygen. That is what lipids are, just long chains of carbon, hydrogen, and oxygen. Every once in a while, we stick in a phosphorus, but that's for particular lipids. Most lipids, fats, and oils are just long chains of carbon, hydrogen, and oxygen. What is their function? And we need to be specific about somebody tell me, what is the function of a lipid? What do we need lipids for? Remember, all macromolecules have a specific function. They can store energy. That's a big one. Because they are large molecules, they have all those bonds. Remember, the energy is actually stored in the bond that holds those elements together. Where we release the energy is when we break those bonds. So because they're very, very large, they store a lot of energy. They create cell membranes. Thank you, Serenity. And the other thing it does for you is insulate you. They're good for insulation. So when we did carbohydrates, the main function of a carbohydrate is short-term energy. But if we run out of short-term energy, we can always go to our storehouse of fat and get some energy by breaking those molecules down. And again, because they are large molecules, they will release a lot of energy. So again, and so put insulation on there too, because that's what keeps you warm. Lipids keep you warm. They also form protective layers around things like your nerve cells. So insulation is the term that we really want to focus on for lipids. So insulation first, they're in the cell membranes. They're very, very important in the cell membranes. When we talk about cells, we'll get into that more. And then lastly, they store a lot of energy. All righty. Characteristics of enzymes. Let me see if we go back to, there's a lot of characteristics, and so we're going to go back in the module. in proteins. Enzymes are proteins. First and foremost, an enzyme is a protein. They are biological catalysts. And the job of a catalyst is to make a reaction happen. So let me see if, oh no, it's faster if I do it this way. So let's go back to proteins. Proteins. All right, so they are a biological catalyst, meaning they're only found in enzymes are only found in living things. Catalysts are found in everything. So again, we have them, we're talking about organic molecules and inorganic molecules. Our enzyme is an organic molecule. Enzymes, function of enzymes. Let's see. There we go. All right, let's see. All right, so that's that first one. They are biological catalysts. Come on, click, click. All right, their job is to make a reaction go faster by lower, and you can just say, we're not going to worry about activation energy. They make the reaction go faster. That's what you need to know. All right. They do this by landing on the substance, and the word substrate is just substance that needs to be acted upon. And it's like when we say catalyst, it's like when we have two people that are arguing and a third person comes along and says, yeah, 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 and they instigate a fight. And so the two people come collide. That's what a catalyst does. They kind of instigate a reaction that probably wasn't going to happen without them. But then they step back, so they don't become part of the product. They make the product happen and then step back. So they do that by landing on the surface of the thing that they want to react. Enzymes are very specific. You have, so then it's released. We have something called the lock and key theory, that an enzyme is designed to fit on a particular substrate. So what works on starch does not work on proteins, and what works on proteins does not work on fats. So each one has its own type of enzyme, and it is named for the subject that it's working on. So if it's working on a protein, then they all end in ASE. So if it's working on a protein, it's a peptase. If it's working on a starch, it's like amylase. If it's working on sugar, like for example, sucrase would be working on to break up a table sugar. So the enzyme is named for the thing that it's designed for, and it only fits on that surface. So you see these have special surfaces where the enzyme will sit, do what it needs to do, and then it leaves. Okay, so that's how it behaves. So this kind of answers those two questions on the worksheet. Okay, so if you can get back to your protein section, that's where, okay, and it says, so what are enzymes? It says the same thing up here. Okay. All right, so that, what is the job? Enzyme, okay. An enzyme in your digestive system works on a disaccharide molecule to break it up into two. What is likely name of this enzyme? And like I told you there, thank you, maltase. Very good. Thank you, Serenity. Actually, when y'all put these answers in the chat, send it to everybody. Maltase, yes, Serenity. You don't have to redo it, but maltase is the answer to number 16. And again, the enzyme is named for the thing that it works on. It's going to end in ASE. So since it's maltose, it's going to be maltase. Okay. All righty. 16. Where are we? 17. Which macromolecule holds the master set of instructions that controls everything in the body? from reproduction of cells to everything else. You can tell me which one that is. The only one we haven't talked about yet. Nucleic acids. Thank you. And thank you for sending that to everybody. All right, nucleic acids. So nucleic acids, again, are not a food substance like the other ones can be found in foods. This is found in the nucleus of your cell. They are the blueprints. We always call them blueprints for what all the things that are going on in your body. They tell you what your genetics, they tell you how to make a protein, how the cell is supposed to operate. All that information is in the nucleic acids, which is your DNA and your RNA. All right, factors that limit enzyme activity. And I kind of answered these earlier. You have to have the right temperature. Let's see if that was back up here. Temperature enzymes don't work if the temperature is not right. Oh, here you go. Here's your enzymes over here. Lactase, protease. So those are examples of enzymes that are specific to, okay, here we go. So we need the right temperature, we need the right pH, and we need the particular substrate that they are working with. So if you put an enzyme in a solution that it's not designed to work on, then it's not going to do anything for you. Okay, so this answers the second part of the question. So if you can pop back up to this section, that'll help you answer that question as well. All right, and that's in the module for proteins. Um, okay. So again, enzymes end in ASE, and those are examples of those things. This over here is the same thing as they had up here. I don't know why they produced it like that, but same thing. All right. We talked about what is denaturization, denaturing. Let me see if they have it written as a statement over here. No, they do not. All right, so denaturing, again, is when the protein has been altered, and it's usually altered because either the pH was too high or the temperature was too high, and it becomes non-functional. So either the pH is too high or the temperature was too high, and it changes its form, and when it changes its form, it does not work anymore. Okay. All right, oxygen and ATP are your energy carrying molecules. And again, ATP is adenosine triphosphate. See what else is on here that oxygen carries energy and ATP. Not oxygen. Shh. Yeah, oxygen is an energy. You can't do anything without oxygen. All right, I'm going to stop and let you work on these true false ones on your own. Again, when you have completed this worksheet, then you can, there is a folder in the module. So that's the right after the worksheet folder. You have another one that says review sheet. So this one is one that you can upload your answers and get credit for having paid attention in class and submitted your worksheet. All right, so I'm gonna let you work on that. All right, and if you run into any questions, please ask. All right, so while you do that, I am going to go in the Nearpod gradebook and put those grades in. And which is always the fun part about doing a Nearpod is it doesn't automatically transfer to the gradebook. So I'm going to stop sharing, stop talking. It's the other energy carrying molecule. That's the one you want. And that is it's got a long, very long name. Just know that that's an energy molecule. Okay. And when we do photosynthesis and AD, we're actually going to do respiration. We're going to run into that again. Okay. NADH. Actually, that's the other answer that you should have in that space. ATP and NADH are the two answers that you should have for that one. And like I said, it's a very long name, adenosine dihydroxide and that kind of thing. But for short, it's an energy molecule. Thank you for bringing that up. All right, how did he get kicked out? All righty, welcome back. All right, so again, finish that worksheet and then upload it. And once you've got that done, that's okay. That happens. Thank you for coming back. All right, yeah, these. A reminder that today is open house. Invite your parents to pop in just for me to say hello and tell them what you. In particular, I'm going to remind them that this is a milestone test, milestone class that you need to be saving all your notes and get ready to take this test in April. And you got to pass it in order to get credit for biology. So what my objective is to get you to keep your class grade as high as possible so that but and I know that's not going to happen to y'all because y'all are bright and wonderful people, that you get the best score that you can on the milestone because it is 20% of your grade. So if you get a low milestone score, it's going to bring your class average down, but we want it to be so that you still pass the class because biology is one of those classes that you must take to graduate. So if you fail biology, you got to take it again. And we don't want that to happen. So that's going to be my little 2-minute speech to your parents. So make sure that they come in this evening to get that. Also, I believe that they are changing out the Chromebooks because Chromebooks are going wacky, wacky. So there's some information they want them to get for that as well. All right, Nearpod. Again, the test is tomorrow. So not only complete the worksheet, but study the worksheet. We are going to try the lockdown browser. The only thing you'll be able to use is that worksheet to help you out. Okay. one. Mhm. Okay, so again, folks, um, with the protein Nearpod, I am looking at, did you, so there's a, you were able to do the climb, time to climb. You need to do that, and you need to do the draw it. So I'm basing the score on that. Yeah, I know there were some other things that you couldn't, so past that, you probably got stuck. So make sure you at least did time to climb and draw it, because some of you did not. So I'm gonna put a score in, but it probably is not the score you want. So if it's not the score you want, go back and make sure that you've done those two activities. Um, yeah, he's in the other class. Okay. Okay. I'm doing this again. Whoa. Okay. All right. I'm all caught up with you guys, and you're all caught up with me. No empty spaces, no missing assignments. That is just wonderful. Again, well, I can go in and make, so if you are ready to upload your worksheet, I'm going to go ahead and open that. So let me edit that so that if you're ready to submit it, you can do that today if you like. Give me 1 second to change the date on that. Available today. All right, so if you refresh your page, um, that folder should be open now. So if you're finished with your worksheet and you want to upload it today, you can go ahead and do that. And again, that's a study page. So you want to make sure you're studying Ms. Grin. You want to study your uh, graphic organizer, and you want to study the answers to those questions. And that's the test, which is tomorrow. Mhm. Then what is Friday? Friday is the 20th. Okay, folks, if you're in a good place to stop, it is lunchtime. You have no questions for me. You are good to go, and I'll see you tomorrow.